Alright, welcome to Unit 9, Notes 2, Monomial and Factoring Review. So learning target. I can simplify monomial expressions and factor expressions. So this is a very good notes video because if you listen to this notes video, you're going to remember a lot. Alright, and this is review, so it's not supposed to be new. So make sure you're paying attention. So, product of a power. Alright, so you got to remember product of a power. You need to add exponents. Right, so that means when you're multiplying, you're going to get this. So a to the 6, a to the 3. So you're multiplying two powers. You're multiplying these together. I'm going to get a 6 plus 3 is to the 9th. Right? Now, power of a power. So that means the power is going to be outside of the parentheses. You're going to multiply the exponents. So what that looks like actually is right here. Right? Technically, this is going to be 6 to the first power. So 6 to the first power, you're going to take the 1 and times it by 2. So it's going to end up being 6 squared, or 36. And then 6 times 2 is going to make it a to the 12th. So that's what you're looking for. Let's flip this around and do it the other way. So look at this. 0 power. When you come across that, you should be putting down 1. Anything to the 0 power is just 1. What do we got here? Division, quotient of a power. So I got 6 over 2. They are working against each other. So I usually say that there's 4 more on top, or 6 minus 2 is 4. So you're subtracting exponents. Quick review there. You're supposed to know some of these properties though. So when I get to this one, if it says simplify the expressions, I look at this one, I see 1 and 2, so I'd say x is to the 3 power. I don't see any other y, so I'll just rewrite it, and I'll just leave this as 4. When I get to this one, what's the product rule? What's the power of a power rule? Alright, so basically, with this little thing, power of a power, you'd be doing 3 times 0 is 0, y to the 0, 1 is 0. Right? Basically, everything ends up being to the 0 power. So if it's out in parentheses, it's good. This one's not going to be very fun. However, one trick that I do is I simplify the inside first. So myself would rewrite the 6. You can't see that at all. So I'll put this ugly yellow with the purple, but 6. Alright, now the y's. There's 1 y in my first underline and 4 in my second. So 1 plus 4 is y to the 5th. Now I see that there's 3 x's and then another one. So I'd actually say this is x to the 4th. And then what I need to do is square that. So now, like I said before, this is like 6 to the 1. So 1 times 2 is going to be 2. 6 squared is 36. Now you have 5 times 2. That's going to be 10. I'd probably write it in alphabetical order. So 6y to the 10th. And then 4 times 2 is 8. This is the best answer I feel like for when you simplify that. Moving forward, alright. Now we have some multiplying to do here. So we have 4 and negative 7. That's going to be negative 28. I think you guys are comfortable with that. Now 1, a to the first. And 2, you add exponents, so 1 and 2 is 3. And then it'd be 6 and 3 more. I would get a total of 9b. I'm guessing there's some quotient ones now. Huh, look at this. So what's the quotient rule? We wrote down that you subtract the powers. So if I look at this, there's 1 on top and bottom. Those are going to cancel out. 1 minus 1 is 0. A to the 0 is just 1, so 1 times 4 is 4, and then you still have a b. When I get to this one, alright, 16 divided by 4, it would be 4. Now if I look at this, I got x, 5 minus 6 is to the negative 1. So if I did this, I'd have 5 minus 6, then I'd have 7 minus 4. So I get 7 minus 4, y to the 3. If I did this off to the side. So this is equal to negative 1, this is equal to 3. Now, what I'm telling you is that if it's a negative exponent, what you have to do is move it downstairs. What I mean by that is anything can be written over division of 1. So what I would write for my final answer is keep the 4, the y to the 3, and then move this x to the positive 1 downstairs. So this is what you need for a final answer. Some people will look at this, and they'll see this 5 and 6 here, and they'll just go, hey, I see that. I know that there's 6 is greater than 5, that means there's one more on the bottom. So whatever it makes you do, you need this 1 right here on the bottom. Now, you don't have to write that 1 there, but you have to know there's one x there. So that's a little bit review for you. So factoring expressions, right? Factoring expressions was technically the first 3 notes in Unit 4. We had factor by grouping, factor by guess and check, and factor by X method. Now, most people are going to go with the X method, all right? And remember, that's A times B. Ooh, that's a mistake. A times C and B. So remember, these are AC squared, X squared, plus BX plus C. These are your values, B, A, and C. Now remember, it had to multiply together to be A times C and add to be B. So those are probably, the X method's probably going to be the most popular. That's what everybody ended up doing last trimester. You could just guess and check, write down these 2, know that, hey, some of these are perfect square roots, like the perfect square root of 81 is 9, all right, and maybe the square root of 25 is 5. So you might see that, and you might know, hey, I got a plus minus 1 for guess and check. So let's look at a few examples here. So steps for factoring trinomials, factoring out the GCF, setting up the x, solve the x, factor by grouping. Note, if a value is 1, the numbers in the x are the factors. All right, so that's the shortcut, and I can show you that myself in a second. So this is kind of the steps for factoring trinomials. That's the X method, all right? Then there's some guess and check and things like that. So if we were to do this one real quick, I would set up this X method. I would say this is a 1. So 1 times 5 is 5. This is 6. Now I need values that add up to be 6, but multiply to be 5. Since 5's prime, I know it has to be 5 and 1. Good news is 5 plus 1 is 6. So since this up here is a 1, what ends up happening is you can write x, it's a positive 5, and it is a positive 1. This is your final answer. I know before we would do x squared plus 5x plus 1x plus 5. We'd do the grouping thing. We take an x out here, a 1 out here. We go x plus 5, plus 1, x plus 5, and then x plus 1, x plus 5. We would write it together since these 2 things were the same. This is your answer. Well, good news. I got it up here already for you. When this GCF is 1 here, you can skip a few steps. All right, with this one, factoring the expressions. This one, since we don't have this plus C here, we're not going to do the X method. Now, one thing you should look at is this step right here. When we did use the factor by grouping, we took out the GCF, and the GCF here was kind of 1x because there was no variable in front of the x squared. In front of this one, though, we see a 3x squared minus 15x when I rewrite it. So I just said x in both of them, so I'm taking out an x. And I'd also take out a 3. So when I factor that one completely, I'd write 3x. 3 divided by 3 is 1. 2 minus 1, we just went over this, is going to be x minus 1x and 1x. These are going to cancel. 15 divided by 3 is 5, and notice I kept the minus sign. This is how I would factor that. All right? Just take out the GCF that you see that's the biggest that goes into both of them. So if it doesn't have a plus C, look for a GCF that you can take out. Sometimes it's a number like 2 or 4, and sometimes it's a variable. All right, looking at this one is going to be a lot of work because I'm going to have to do all the factor by grouping steps since that a value is not 1. So now I got to do the extra work. But 3 times 2 is 6, and this is 7. So kind of like last time, it's going to be 6 and 1, I believe, because 6 times plus 1 is 7. So I would come over here. I would write 3x squared plus 6x plus 1x. Remember, these two replace the middle, plus 2. So then when I have that, I got to group it like this. All right, when I see the 2, I just think 1. When I see this one, I actually see a 3 and an x. So I can rewrite this one as 3x. 3 divided by 3 is 1. 2 minus 1, this is x. X is canceled. 6 divided by 3 would be a plus 2. Plus 1, because that's my GCF in the second group. The 1's cancel. I still have an x, though. And 2 divided by 1 would still be plus 2. So since these are the same, that's when I jump to the step of 3x plus 1 and x plus 2. Now, one thing to note, this is much different than 6 and 1. So because this 3, so I'm underlining the 3, is not a 1, that's why you got to do the factor by grouping work. But this is your correct answer down here, and now we can reduce things if possible. Reason this one is on here is because this is x squared minus 49. This is actually a perfect square root 1, meaning I can see that that's a 1 there, and the square root of 1x squared and the square root of 49 are things that we know, all right? It is going to be x, and it is going to be 7. But now I know that I need 2 groups of them, so it's going to be x, and it's going to be 7. But one is going to be plus, and one is going to be minus. All right, so the square root there, noticing that is a perfect square root, is a good ability to have. The other fun fact of that is a equals 1 here, c equals negative 49, and b would actually equal 0. It's not here, so we know it needed to be 0 times x. Well, one thing is if you set up the x method, you would have had a times c, so negative 49, and you would have had b as 0. You should kind of recognize that that's 7 and negative 7, and guess what? This value right here is 1. So this is going to be your final answer, which I originally wrote in black. So there's a couple different ways to understand those perfect square roots. You have to know, or you have to remember how you're going to do it on your quiz. Hint, hint. All right, then we got a couple more, factoring the expression ones. All right, this one I can do with the x method probably. This is a 1, so 1 times negative 35, we'll say negative 35. This will be a 2. All right, I would say this has to be negative 5 and 7. All right, I get that because I'm good at math. And negative 5 plus 7 is 2, and negative 5 times 7 is negative 35. So I'd rewrite it. I don't have to rewrite it. I can notice that this is x minus 5 and x plus 7, and I'm done. This is your final answer here. Now this next one, I know I'm going to have to do a little more work. I got 2 and negative 3. So 2 times negative 3 is negative 6, and then this middle is negative 5. So I'm going to go ahead and let you know that I need to multiply by a positive and a negative, and so that negative has to be the bigger value, which is 6 and 1. So I'd probably replace the middle. So 2x squared, so these have to go in for the middle one. So it'd be plus 1x minus 6x minus 3. And this gives me a chance to work with negatives. So this is going to be x. The first group's always got an x, but 2 and 1 don't really leave me much. This is going to give me x times 2x plus 1. Now, seeing that I need 2x plus 1, I'm going to want to divide this by, and I'm going to write it in blue here, a negative 3. Because dividing by the negative 3 is what's going to make a negative 6 divided by a negative 6 a positive 2x, and a negative 3 and a negative 3 is plus 1. So I look at this 2x plus 1, and I made these match by switching this to a negative 3. That's the key there in figuring these out. Now, x minus 3, 2x plus 1 is going to give me the factored expression completely. All right, moving on. Oh, that's it. Good work, team. All right, make sure you're comfortable with those, and you have any questions. Your ability to do those is on the next test. Good work, team.